Good afternoon, students. Today we will be concentrating on this particular topic, which we have done several times. However, the syllabus goes, we have to do that. Let us see. Um, Fingerprint region and its significance. Now, what is the fingerprint region? I think I have already discussed this part. It is the region from around 1450 to 600, or you can say around 400. Okay, that this portion literally means this is the fingerprint region. Okay, which is quite complex. You can see that it is quite very complex with intense, strongly intense and weakly intense peaks. Okay, so here what we find is each trough is caused because energy is being absorbed from that particular frequency of infrared radiation to excite the bonds in the molecule to a higher state of vibration, either stretching or bending. This also we have discussed how we are getting this peaks. This is because of the absorption of particular frequency of infrared radiation. Some of the troughs are easily used to identify particular bonds in a molecule. For example, a big trough at the left-hand side of the spectrum is used to identify the presence of oxygen-hydrogen bond in an OH group. So you can see this. This is quite a broad one. So we have this point that it is a group for OH. I mean, this is a peak for OH group. Okay. So this is therefore we can understand this can be alcohol. So this particular side, left side of the spectrum, gives us the idea of the functional group present in the molecule. The region on the right hand side of the diagram, that is from about 1500 to 500 centimeter inverse, usually contains a very complicated series of absorption. These are mainly due to all the manners of bending vibration within the molecule. So these are mainly for the bending, for the overtones, and some of the C single bond and C single bond O, those type of stretching frequencies. Okay, so therefore these are mainly due to the all manners of bending vibration within the molecule. This is called the fingerprint region. So mainly, you have to understand this word mainly. Okay, so it means apart from this bending vibration, there can be stretching vibrations also. So it is much more difficult to pick up individual bonds in this region than it is in the cleaner region, that is in the left hand side at a higher wave numbers. The importance of the fingerprint region is that each different compound produces a different pattern of troughs in this part of the spectrum. Okay, so therefore it is just like a human being's fingerprint. Okay, so therefore this fingerprint is unique, and here also this fingerprint region is unique for a particular molecule, and it will be quite different from the other molecule which looks to be much similar. So you can take the examples of ethanol and propanol. Both are alcohols with a small difference, but yet there will be the fingerprint region will be completely different. Okay, it is much more difficult to pick up. I think we have done this part. Okay, using the fingerprint region, what are the things we can get from the fingerprint region? Now compare. Now we have to take here two similar compounds. Okay, propanol 1 and propanol 2. Both the compounds contain exactly the same bonds. Both compounds have similar troughs in the area around 3000 centimeter inverse, but compare them in the fingerprint region 1500 to 500 centimeter inverse. So there you will find that there is a complete difference. See the spectrums here. So let me take it. So see the spectrums here together. So you can see these parts are very similar, very similar, but however this part is completely different. Okay, so this fingerprint region tells us that even though the functional group is same, the compound is quite different. Okay, so here it is showing the bending vibrations mainly. Okay, the pattern The pattern in the fingerprint region is completely different and could therefore be used to identify the compounds. So, to positively identify an unknown compound, use its infrared spectrum to identify what sort of compound it is by looking for specific bond absorptions. That might tell you, for example, that you had an alcohol because it contained an OH group. So mainly we can concentrate on IR spectrum to identify the functional group, and with reference to some known spectrum, okay, we can compare and we can get some idea about the rest of the molecules part. Okay, you would compare the fingerprint region of its infrared spectrum with known spectra measured under exactly the same condition. Now you have to understand this part, because we have already discussed about solvent and without solvent, KBR, this vapor phase, liquid phase. So whatever, under whatever condition you have taken the spectra of the unknown compound, you have to go for referring the spectra of certain known compounds, okay, but the both should be done under the same circumstances, same condition. Means if one is done in the liquid phase, other should also be done in the liquid phase. Okay. Now we will see another thing, that is application of functional group analysis. So this part we will be requiring, and with that we will be looking into the spectra, and we will try to identify the functional groups. Okay. So we have taken here one spectra, and so that we can refer to this data continuously, I have kept it separately also. So let us look into the data and the spectra side by side. So you can see here 2971 and 2863. There are certain spectra, peaks here. Let us look into the data. So here, if you look into this total range, it falls under this category and this range, and therefore we can conclude that it is for C8 stretching, that is for sp3 C8 stretching. So we have here C8 stretching, and apart from that, what are the other groups? We have here 1470. So if we look into this, so 1470 and the other one also falls under CH band. So we can conclude here that we don't have any other functional group apart from saturated alkene. We don't have here any nitrogen, nor we have any kind of oxygen. So we can tell that we don't have double bond, we don't have triple bond. So it is only an alkene. Okay, let us but however we cannot refer here what is the number of carbons present. Okay, that is a for that particular information you have to take help for other spectra like invisible, NMR, all those. Okay, so presently we can conclude what is the functional group. Okay, so that is why application of IR is mainly in identifying the functional group. Okay, so let us go to the next spectra. What we see here, these are there, but apart from that there is a weak peak in the region 3083. Apart from that, there are two extra peaks when we compare this one with the other one. So we got these two, okay, fine, it's there also, but we have three extra peaks. So what are these for? If we go into the data to refer with, so we will find that it is matching with this particular range. Okay, so we can conclude here that it is having it is an alkene. Okay, it is an alkene, and therefore we have this is we can conclude that it is an alkene with the presence of double bond, as well as there are certain other alkyl groups also. So it is a longer, you can say it is a long alkene. Okay, what is the number of carbon, that we cannot tell, but however we can tell it is an alkene. Next one, here you can see there is an intense peak at 3324. So if you go into the alkyne data, or if you go into the total data, you will see here for alkyne particularly there is 3300 sharp strong peak. So it is very clear that it is having a triple bonded triple bonded carbon with H. So we can say it is a terminal alkyne. Okay, if you don't have this one, we cannot say it is a terminal alkyne. But if you have this one, you can say it is an alkyne, but if the triple bond is within the chain, which means it is in between the chain. So if you have only this one, we can say it is an alkyne, and the alkyne is at terminal position. Okay, because you have CH stretching here. You have CH stretching. If the alkyne is in between, you will not have CH stretching. You will have C triple bond C, and with that you will have C single bond C, which is very invisible. It is not visible. So therefore, what you have more, you have here C triple bond H bending also. So therefore, it confirms that the alkyne is a terminal alkyne. Okay, very interesting if you read it properly. Next one, what you see here, you see definitely CH groups are there. CH group is definitely there. It is CH bending is also there. CH rocky and CH bending is also there. But here we have more different peaks, that is 3099, 3068. So if you go into the data here, data will tell you that it is definitely having an aromatic ring along with alkyl group bonded to it. So we can say it is an aromatic ring along with alkyl group bonded to it. So it is not benzene, but it is the higher derivative of it. It can be toluene. Next one, it is very clear that it is this broad peak is for OH. It is very clear. Along with that, there is CH group. Okay, so it is clear that we have this one as what? It is an aliphatic alcohol. You have CO stretching also. C bonded to O is there. Okay, so here it is what? It is an aliphatic alcohol. Next one, if you see here, what you get is you are getting a very clear C double bond stretching. If you look into the data, the same result you will get. Along with that, you are having CH groups. Okay, so CH groups, you do not have any stretching in the region, and that is for C double bond O, C double bonded CH stretching means sp2 carbon a hydrogen stretching. So it is clear that it is not an aldehyde, it is a ketone. Okay, because you do not have, there is an absence. If you go into the next graph, it will be much clear whether it is ketone or aldehyde. In case of aldehyde, what you have is, in case of aldehyde, you have this type of peaks are there. Okay, what are these peaks? These peaks are for CH, but it is for aldehydic CH stretching, and it is for alkyl CH stretching. Okay, so therefore it is what? It is an aldehyde, and this is a ketone. Next one, if you if you see this, what you have, it is clear that it is an aromatic. Okay, CH stretching, very weak bonds are there. Along with that, you also have a very small number of CH alkyl groups. So the number of alkyl groups present here is quite less. Okay, but aromatic stretching, you know, it is always weak. If you refer the data, it will tell you that it is very weak aromatic. Okay, this is very weak. I'll show you this one. So these are what there are weak